Um, I mean, I guess. Uh, I mean, I have a new teacher right now, so it's like things are a little bit different right now.
Okay. So can
I
you
could,
do you have some problems that are the kind of stuff you're going over in class right now?
yes.
Okay. If you can verbalize those, let's tackle some of them.
All right. Do you want me to email you the
You can
problems?
do it in two ways. You can verbalize them, or some problems can't be verbalized. In other words, if they're giving you a graph and they're asking you, what's the equation of that line, you can't really verbalize the graph. But most problems can be verbalized.
All right.
It's good for you to try to verbalize them if you can, merely because it's something you don't get a chance to do very often. How
Yeah.
often in class do they have you stand up and verbalize a problem? Not very often, I'm guessing.
Yeah.
So with a lot of students, it really helps to let's verbalize stuff. It'll
All
help
right.
solidify it in your mind.
All right.
Let's try one where we verbalize it.
All right. All right. So do you want me to just tell you the problem?
Just read the problem to me and I will
Okay.
write it out.
Okay. Okay. Uh, okay.
Go ahead. Yeah.
Okay. It says in square WXYZ, the angle W is 50 degrees more than MX. Sketch the WXYZ. Find the measure of each interior angle. Then label each angle with its measure.
Okay. First of all, having a little hard time hearing you. Um, Reread the problem just a little bit slower.
Yes. In the square YX, oh wait, Y WXYZ,
Okay.
the angle of W is 50 degrees more than angle X. Sketch the WXYZ and find the measure of each interior angle. Then label each angle with its measure.
Okay. Well, here's our square, right?
Yes.
Okay. And they said the measurement of angle W is 50 degrees more than angle X.
Yeah.
Well, that's problematic right there because both of those angles are 90 degrees if it's a square.
Yeah.
Hold on. We're talking just a second.
So
So I'm a little confused. You sure it's a
what?
um hmm. Maybe it would be better if you go ahead and take a picture of that page. Is it on paper
Okay.
or is it on a website?
It's on paper. I have
Take a
a
picture of it
yeah.
and send it to this email. Here, I'm going to write my email up here.
All right.
Make sure you send it to this one. I have a couple of them. This one gets to me the most direct. That's an N 1949 at Gmail.
All right.
Yeah, I'm a little confused. Just there must be more in this picture that I've drawn than I'm thinking.
Yeah. One sec. Uh,
Geometry is definitely the toughest thing to verbalize, um, just because it almost always involves shapes, figures, squares, rectangles, parallelograms, things like that.
yeah. All right.
and tell me when it says file sent. Are you using an iPhone?
No, I'm using Samsung.
Okay. Better still, you don't have to choose the file size, I don't think.
No.
But do attach it. Send it as an attached file, not an embedded file.
Okay. All right, there you go.
Not received yet. Does it say file sent on your end?
Yeah.
Not sending? It said file sent.
Yeah, it's sending right now.
Well, that's not the same. Tell me when it says file sent. Because it takes a while to send it. There it is. In other words, I'm not going to get it until it says file sent.
Yep.
Now, there's a little bit of problem here. Let me see if this happens. Ah, there we go. About that. Sometimes you want it rotated.
Yeah.
So which one are we looking at?
We are looking at number 10.
Okay.
With WXYZ.
Okay. First of all, that doesn't mean square.
Oh.
That means in parallelogram, I believe.
Yeah, we're learning about parallelograms right now.
WXYZ. Yeah, that looks like a parallelogram. Okay. So that is possible. Here, let me write on here. So I'm just going to draw a parallelogram up here. And it's W, X, Y, Z. And if angle W is 50 degrees more than angle X, then, okay. Find the measure of each interior angle. Okay, when you're dealing with parallelograms, adjacent angles always are what?
Wait, what?
Adjacent angles. In other words, W and X are adjacent. They're not opposite. They're adjacent.
Yeah.
And in all parallelograms, they are supplementary.
Yeah, they equal 180.
They equal 180. So we know that W plus X equals 180. And we know that W is X plus 50, right?
Yes.
So I'm just going to substitute X plus 50 for W. Now solve that equation. Over here on the lower right, where I've written the equation.
All right.
How do you solve it?
Is it so I distributed the X to...
There's nothing to distribute. In other words, I can remove the parentheses
Oh,
without
okay.
doing anything.
So you add like terms first?
Okay, what's the next step?
And then...
You have X plus 50 plus another X equals 180.
Okay. So you'll add the two X's to equal 2X?
Okay, so now I got 2X plus 50 equals 180.
And then you have to add... So you have to subtract 50 from both sides.
Okay, now I got 2X equals 130. And finally what?
And then 2... So 130 divided by 2.
Okay, so X equals 65. Do you have a calculator in front of you, Ricky?
Yes, I do.
Okay, cool. Okay, so let's go back up to this figure I drew. X equals 65. What's W?
Is 50.
W is 50 degrees more than X.
Oh.
If x is, we just solved for x, it's 65.
Yeah.
What's w?
115.
Okay. Now, you can tell right away I haven't drawn the parallelogram correctly, right?
Yes.
So it must be a parallelogram that looks like this over here on the right. That's okay. You don't really have to draw it correctly, but this certainly makes more sense, right?
Yes.
Okay, and this is W, X, Y, and Z. What is Y?
Is 115.
Right, opposite angles are the same in a parallelogram. So Z is
Yes.
also 65.
Yes.
And that answers, I think, everything.
All right.
Okay. So, I didn't really need to redraw it. In other words, even though I drew it wrong, I still have the right answers, right?
Yes.
In other words, X is still 65. W is still 115. So my picture may be off, but it doesn't really matter, as all I'm doing is using math. I'm not using the picture after I just started it.
Yes.
So this step over here of redrawing it isn't really necessary. You don't care if it's off. It's the numbers that matter. It's the fact that you know that opposite angles.
Yeah.
So in this one, I'm just going to draw it like this and not care whether I've drawn it correctly or not. And this is E, F, G, H. Okay. So angle G is 25 degrees less than angle H.
Yes.
Same question. So tell me what you know about G and H. You know two things.
That they're supplementary.
Okay, so G plus H equals 180. What else do you know?
That G is 25 degrees less than H.
So put that in an equation.
All right.
G is what? Or G plus or minus something is what?
G minus 25.
Give me an equation.
Okay.
Everything needs to be put into an equation that you have to solve. What
Is
if
it
I wanted to put H over here? Now, how do I handle the 25 degrees? With a plus 25 or a minus 25?
minus 25?
Let's try a plus 25.
All right.
Which angle? In other words, if H was 100, G would be 75, correct?
Yes.
No, excuse me. G would be 125 if H was 100. So
Yeah.
G wouldn't be 25 degrees less. So I got the wrong sign on it. This has got to be a minus sign. Now, if H were 100, G would be 75, correct?
Mm-hmm.
So we know how we've got the equations correct. Now what? In other words, now I have a system of two equations that I have to solve. Everything I know about parallelograms is in those two equations and the information they gave us. Okay.
All right.
How do I solve this? First of all, remember your systems of equations. You can solve them by substitution or you can solve them by elimination. What's a good way to solve this one?
Elimination.
Substitution. Whenever you have one of the equations that's fully defined in one variable, like this one is, G right here, we know what G is. It's H minus 25, okay?
All right.
So now let's go to the first equation and substitute what we know g is. So tell me what to write.
Ooh,
In other words, you're going up to equation number 1, and wherever you run into g, you're going to substitute h minus 25.
oh, is it?
Start from the left. What's g?
I don't know.
Okay, what's the second equation say?
G equals h minus 25.
Okay, now let's go back to the first equation. What is g?
H minus 25.
That's what that equal sign means.
Oh.
Wherever you see g, you can substitute whatever's on the other side of that equal sign. So h minus 25 instead of g, I'll put parentheses around it, plus h equals 180. Now, here's the reason we did that, is because now we have one equation with only one variable. You can always solve those.
Yes.
So we're going to be able to solve for h in the same way last time we were able to solve for angle x. But it's hard. When you only have one equation and two variables, you can't solve it. You cannot solve equation 1 by itself, and you cannot solve equation 2 by itself. But by combining the two of them, you can produce this third equation that's only got one variable in it. Now, solve that. Remove the parentheses and combine like terms.
Yeah.
Get all your variables on one side of the equation, get all your numbers on the other. That's pretty much the methodology you want to use to solve all equations.
Yeah.
Remove your parentheses, combine like terms, and get your variables on one side, your numbers on the other. So,
all right.
First.
So I got 2h minus 25 equals 180.
Okay. Now what?
And then you add 25 to both sides. And then you subtract 20.
Hold on. When you are solving equations, what you're doing is trying to get rid of everything except h. Okay?
All right.
Currently, there's a 2 next to it. What is that 2 doing? Is it multiplying, dividing, adding, or subtracting?
Multiplying.
So what do we have to do? We got to do the opposite.
Divide.
Divide. In other words, the opposite of addition is subtraction. The opposite of multiplication is division. If we were dividing h by 2, we would be multiplying by 2. So you're always doing the opposite. So since that 2 is a multiplier, we need to divide.
Yeah.
So what's h equal to?
102.5.
Okay. So now let's go up here into our diagram, if you can see it. We know that angle is 102.5. So give me the other 4 angles.
All right. So F would be 102.5.
Good.
And then the E and G would be 77.5.
And in this case, I happen to draw it correctly. But again, had I not, I wouldn't have really worried about it.
Yeah.
Okay. We got about 10 more minutes. Do I got more problems on this thing?
No, I did most of it because I actually understood what I was doing.
Okay. You got any other problems you want to cover?
I mean, I guess there's one more.
You want to check these ones you did? You want me to check them?
Yeah. Yes, please.
Okay, let's see. Number 7. let's see, is all we're doing is solving for everything here?
Yeah.
And so is that thing that I'm pointing at a G?
That
Oh,
is,
no, there's the G.
yeah, that's the 5.
That's a 5. All right, here, let's just, I'm having a little bit of a hard time following your work. So
Oh, yeah.
let's set it up so that, what do
Oh,
we do?
it's
Okay, that's 8G. What's minus? Oh, you put a dot between
yeah,
G. You
because
probably shouldn't do.
3.5.
Yeah, the reason is it makes it confusing for anybody reading.
Okay.
When you have a letter and a number together, that's all you need. I do not need a dot between those two. I do need the minus sign, and I know that that's equal to the other side.
Yeah.
So that's the equation that we should be looking at. And let's see, what did you write? 8 times G.
3.5.
Oh, 3.5. Why 3.5?
Because so I'm trying to so both sides
Both
has
sides are equal.
3.5.
In other
So
words,
what?
this side right here is equal to that side whenever you have parallelograms.
Yes.
So all you want to do is you want to take that and make it equal to the other side.
Yeah.
Now solve that equation. Okay, so you solved it, but you just didn't show how you solved it. How would we solve it? Tell me how to
Okay.
solve that.
All right. So add 3 to both sides.
And then
And then divide 8
divide
on
by 8. Divide both sides of the equation by 8. That's what you're doing right there.
yes, and I got 3.5.
Okay, that's fine. I just wanted to make sure you knew how to do the algebra.
Yeah.
And what's the next equation that I'm going to use to solve for f? Give it to me as an equation.
F plus 30 equals 180.
No,
No?
it's adjacent angles that are equal to 180. What's the adjacent
Oh,
angle that you know of here?
72.
Okay, so it's f plus 30 plus 72 equals 180, right?
Yes.
In other words, f plus 30 is that angle right there. So
Mm-hmm.
that angle plus this angle is what is supplementary always. Okay.
Yes.
And then here, pretty easy. F plus 102 equals 180. F equals 78. You will find in geometry a very good skill to have is subtracting numbers from 180, as I'm sure you realize by now.
Yeah.
In other words, if there's anything you want to be able to try to do in your head, it's that. Merely because you have to do it about 100 times a week. Whenever you're working with geometry, 180 is the magic number. Whether
Yeah.
you're talking about triangles or whether you're talking about supplementary angles. In so many of these figures, 180 is a magic number. Okay, so let's have a look at 8. We have a few minutes left. I assume there's no instructions above this.
It just says find the value of each variable in the parallelogram.
Okay. So let's start. What should we start with? I'm just going to cover up what you've written here,
All right.
just because I want you to think about it a little differently.
Okay.
I want you to write out everything you know as equations. So give me an equation that solves for n, as in Nancy.
2n minus 1 equals 9.
Okay, solve that. That's pretty easy. You can give me the answer just as n equals if you want.
Yeah, 5.
Okay. Now, can you solve for m?
So I did m plus 8 equals 3m, and that would equal 2.
So how do I solve that equation?
Com combine like terms.
Okay. Should I bring the m's to the left or should I take them to the right?
To the right.
Why? That is correct.
Because I would get a negative, I think.
Because it leaves you with a positive coefficient in front of m. In other words, at some point in all equations, when you have your variable on both sides, and you're going to combine your variables, you have to decide, am I going to put the m's on the left or am I going to put the m's on the right? Well, if I put them on the right, it'll be 2m, positive 2m. So I definitely want to do that. If I bring them to the left, I'll have a negative 2m, and then I'll have to take the 8 to the other side, and it'll be negative 2m equals 8. Well, it's better to leave the 8 on the left side, subtract 1m from both sides, and now I got positive numbers everywhere. And m equals 4.
Yeah.
Okay. Let me just take a quick peek at number 9. Give me some equations to write.
Fg minus 9 equals 3j.
Okay. How are you going to solve that? Looks like you've made a mistake there. That's not right.
I did.
How do you solve that equation? First of all, which side are you going to put your variables on?
On the right.
No. That'll give you a negative coefficient.
Oh.
In other words, if I move this 3j over to here, I got to subtract 3j from both sides. I'll be left with 2j. There's my positive coefficient. So I'm going to move that 3j to the left, and means I got to move the number to the right. There you go. J equals 4.5. Okay.
So that's
because you moved the 3j to the left, but you added 3j to both. Instead of subtract, remember, you always got to do the opposite. If there's 3j over there and I want to get rid of it, I got to subtract 3j.
All right.
Okay. And then the other equation is going to be what?
K plus 10 equals 6k.
Do we know that these are equal?
Yes.
In other words, I don't see any notation in this diagram like they do here where they have hash marks that tell you they're the same.
Oh, I wrote that.
Oh, you put those in?
Yeah, I put them there.
Okay, so all of these are parallelograms, and the rule for parallelograms is the diagonals bisect one another.
Yeah.
So as long as you know this is a parallelogram or a rectangle, then you know that that's equal to that. So you get that equation. Which side am I going to move my variables to? The right side or the left?
The left.
Which side gives you a positive coefficient? Go ahead and move it to the left. What do you get? In other words, you're talking about moving this to there, right?
Yeah.
Okay, in order to do that, you would have to subtract 6k from both sides.
Oh.
That's going to give you minus 5k. Then you're going to have to move the 10 to the right, which makes it minus 10. Now I got nothing but negative signs. Avoid
Yeah.
negative signs at all cost.
All right.
So you want to move everything, not everything, just the k's, to the right by
Ah,
subtracting 1k from both sides. Then I'll be left with plus 10 there. I'm subtracting 1k. Notice I now have two positive coefficients. Don't have to
yes.
worry about negative signs. K is equal to 2.
Uh,
Okay?
all right.
Ricky, I will let you go. You have a good rest of your day.
You too.
Okay. Bye-bye.
Bye.